do it. Review day chemistry. I want to go through these questions first, right? These are the practicing naming ionic compounds. That was the last piece of new information before we start up anything else before the test, right? Test is on E-Day. We're on D-Day right now, so test is on E-Day. So I'll do these review questions, and then I'll kind of go backwards if you get, I mean, this is just like my little workspace that I've been using here, but I'll kind of go backwards and I'll look at some concepts. I'll just highlight some things that you should really, make sure you remember how to do certain things. My notes go back like quite a ways here, actually. How far back does it go? All the way back. Yeah, it goes back quite a bit. This was like page 1 and then the examples. So yeah, I go back far enough. So all that being said, which is really lovely, let's get started right here. Let's take a look at these. So if we had to name these compounds, right, then this NH4 is a polyatomic ion. It's on table E. It's called ammonium, right? And then Cl is an element. It's chlorine, but because it is an element that's the non-metal, we change the ending to IDE, so it's ammonium chloride. Another little note is that because ammonium only has one charge, right? There's no parentheses here because you only use parentheses for elements that are metals that have more than one possible charge. And we use the parentheses with the Roman numeral to clarify what exactly is the charge of that metal. Super dehydrated. Y'all should hydrate if you're not. So this one, Fe, if you look on your reference table, Fe is number 26. And if you look in the top right, I mean, this is my right, I don't know if it's your right, but in the top right corner, you should find that it has +2 or +3. So we need to figure out which one it is. But I do know that it's iron, and I need parentheses, so I leave them blank for now. And then I name this as nitrate. Right. Now, I know that this is nitrate because this is a polyatomic ion, NO3. And if I check table E, I would find not only the name, but I would also find the charge. The charge on nitrate is -1. And according to this, I have 3 of them. So I have 3 -1s for -3 charge. In order to balance that out, I need iron to be a +3. So the number that I'm going to write here is a Roman numeral 3. Right? And I would do the same thing with the next one. Ti is titanium. It needs parentheses. Titanium actually I think has 3 options also. And this is bromide because, right, that IDE ending for the non-metal. Now, I do have to keep in mind that I have 3 of them. If I look up bromine, the only negative charge is -1. Because I have 3 of them, that's a total negative charge of -3. I need to balance that out. I need to cancel it out, so I need the titanium to be 3. Cu is copper, right? I need parentheses. It could be +1 or +2. P is phosphorus, right? There's that IDE. If you wrote out phosphoride, I wouldn't take off for it right now. I would mark it as correct, and then I would give you the note like, hey, it's really supposed to be phosphide. I know that it can be hard to keep track of like which ones are which. Generally, anything that ends in -ene, like INE, like chlorine and bromine, or actually no, I can't even say that. It's super inconsistent. I blame the English language. I don't know if this was originally done in English, but I blame the English language. Side note. Okay, so this phosphorus, this P, when it is negative, it has to be a -3, which means to cancel it out, I need a +3 charge, a total of +3. So I need +3, but I also have 3 coppers. Because I also have 3 coppers, I'm going to split the +3 3 ways. So 3 divided by 3. Well, that's 1. The charge on this is just 1. Right? Sn is tin. I need parentheses. Selenide is selenium. And this one is 4, because selenium has a -2 charge. There are 2 of them, so it's a -4 total. So +4 is what tin has to be. This one here is gallium arsenide. You should notice that there is no parenthesis here, because gallium only has 1 possible charge. Next one is lead, parentheses. This is sulfate, right? If I look it up on table E, that polyatomic ion is sulfate, SO4. It has a charge of -2. So I have -2 on the sulfate, but I have 2 of them. So it's a total of -4, which means the lead has to be +4. This one is beryllium hydrogen carbonate, because beryllium only has 1 possible charge. I do not need to worry about the parentheses. The last one is manganese 3 sulfite. Right, watch that ending. This is a 3 here, and this is a 4 here. That's why they're different. I know it's manganese 3, and let me erase that circle because it may be hard to see. Excuse me? Hello? 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 What? It's freaking out. My computer is freaking out on me. I would appreciate it if you didn't do that, computer. That'd be totally awesome. Oh, there. Okay, it erased. Down here, right, SO3 has a charge of -2, but I have 3 of them, so it's a total charge of -6. Means I need a total charge of +6, but I need to divide the +6 by 2, because there are 2 manganese, so that's why it's manganese with a 3. Alright. So naming ionic compounds was really the last thing that we got our hands on. Alright. Before that, we talked about just... Before that, we talked about just finding the individual oxidation state, or finding the individual oxidation number. It'll probably be something like this, where you have a combination of 3 elements, and one of them has many oxidation states. It might be chromium, it could be phosphorus, it could be sulfur. They're a handful. But do your best to remember how to do this. Again, I had a separate video. I think I did two videos, basically. One of them was kind of try this on your own, and then one of them was going through these examples. But going through oxidation states, right? Another thing that you should recognize, you should kind of be able to do, is recognize the difference between how to identify an ionic compound, which is something with a metal and a non-metal, or something that has a polyatomic, and molecular compounds, so something that has only nonmetals. Right? Please remember that empirical formula is oddly specific. If you see empirical formula, you need to reduce the numbers down as far as possible. All right? I can guarantee there's going to be at least one empirical formula question. Probably exactly one. All right. Going back to, chemical formulas and counting, right? Counting is not a difficult, no, that's a lie. Counting is hard. Make sure that you remember to distribute if you see parentheses, right? So if you see a 4 inside the parentheses and a 3 outside the parentheses, that means 12. Okay, please remember what that means. You have to distribute, right? And then going back to the first day where we talked about molecules and formulas, diatomic molecule. This is a big red flag question. It's a big, alarm should be going off in your head. Diatomic molecule means think the Brinkel... Nope. There. Think the Brinkelhoff buddy system, alright? It's these 7 elements. Bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, fluorine. I don't have anything clever other than the Brinkelhoff buddy system, but again... Diatomic molecule is like a big red flag. Brinkelhoff buddy system. Which of the following is a diatomic molecule? Which of the following elements exists as a diatomic molecule? Brinkelhoff buddy system. Alright? Okay. Going backwards from there, our atomic structure information, right? Make sure you remember what we know about the atom. It's neutral. It's made up of protons, neutrons, and electrons. Where do we find protons? They're in the nucleus. They're positively charged. They have a mass of 1. Right? Neutrons in the nucleus, neutral, have a mass of 1. Electrons outside the nucleus, negative, have a charge or have a mass of 0. Right? If you see, where is it? If you see this notation, right, this notation here where it's the symbol dash number. Right? The symbol is the element, obviously. And then dash number, this number tells you the atomic mass. Right? Now atomic mass is the total number of protons and neutrons. So I could have Na-25, or I could have Na-23, I could have Na-24. They all exist in some way, but we use them slightly different purposes. They are isotopes. Isotopes are an atom of an element that has a different number of neutrons. So Na-25 and Na-23 are both Na. They are both sodium. However, they have different numbers of neutrons, so they have different mass numbers. Right? Remember how to identify an isotope. Also, you should remember how to identify an ion. Ions are charged, right? Because they have gained or lost 1 or more electrons. Electrons are the only things that are allowed to move. You cannot change the number of protons, because changing the number of protons changes the element you have. And then you're into a crazy different thing. All right? And then another big deal. Your atomic structure basics, again, just remember that first we thought it was a small thing, and then we're like, oh, there's an even smaller thing, right? We have a nucleus, electrons are on the outside. Oh, the chemical change words. Please don't forget your chemical change words, right? These words up here that are all the way back on page 6, which is basically 1,000,000 years ago now. We've been in school for like 2 months, guys. These words. Right, please remember that these words are chemical changes, and the phase changes, melting, boiling, freezing, condensation, those are all physical changes. All right. Now, there are still many examples, right, that we didn't do altogether. And there are also blank versions of all the notes online on the main bulletin board page, not on each individual topic, but the main bulletin board has all of the blank notes. So if you do want to go back and try to do some of these examples again, you can do that and you can check yourself, right? But that's it. The test is on potentially anything from pages 1 through like the notes on page 24, the examples down here on page 25. These examples here that we did not do, I'm not going to ask of you. I'm only going to ask you something like this, where you have a formula and then you have to name it. All right. But that's the last piece, right here. Notes on page 24, examples on page 25. I didn't include page 25 because there are like new notes up here that I did not do. So, if you have questions, please email me. If you don't email me, I'm just gonna figure like, okay, you must think things are fine. It will be difficult to get to me on like in the morning, just because you'll probably be competing with a bunch of other people who have last minute questions. So try to go through, look at the notes, maybe like summarize them on your own. Remember that the test is actually open note, but the test is a lot of questions. So it's not going to do you much good to only know how to look things up in the notes, because the number of questions is going to be quite a few, like 35, maybe 40 questions. So you do need to know stuff. Now, I will say that like once you're reading a question, you should be able to read it and kind of know where to go right away. All right. Yeah. That's all I got. I think, really, if you have questions, please email me. Otherwise, I will see you on E-Day, and your only work, right, your remote work is just to study. Make sure you're prepared for this, all right? Until E-Day, kids. I'll see you. Take care.